Hello everybody, I'm back in OTTD with a very interesting thing that's let's say kind of maybe not new, but let's say new approach to flip-flops, at least for me. And we have over here, let's say, simplified way of building flip-flops. This is one to two directions, and it doesn't use any NOT gates, any memories, any long trains in a special loops that could control the flow through this splitter. And as well, the resources that I used are very limited. We have only one train that controls the splitter. The same 1 to 3, we have two trains that control those this splitter. Now 1 to 4, we need only 3 one-engine trains, and here's an example. Probably never will anyone will use 1 to 5, but I wanted to build and check if this is working. So 4 trains, and this is not very complicated. If you compare those designs to the designs of let's say old designs, you will see that this is a really simple one. I built over here a special testing device that shows if I'm right or wrong about the even distribution, if I made mistake or not. So we have some kind of lines that are actually representing those 5 branches, and each of those got 30 blocks. So already the trains went from the top to bottom. Now it's going back. They are going back, and as you can see, they stick in line. It means that there's even distribution of the trains along that splitter, so it goes well without any mistakes perfectly. Now I started with this one, and actually this is not entirely my idea. I did have a let's say idea to make something like this when I was doing this up and down counter. I built it first in this way, but it didn't work perfectly. But I've got over here idea of shifting the trains along the loops, and I was trying to build this. I didn't get a good result, and then I recalled that in old public game there is something similar, and I found it. So I want to first show the, let's say, the original version of it. What we see on the screen is an old design made by somebody who called himself RB98700, and it's very similar to this one I showed you just before, and it's marked experimental. You can find it in old public server game 239, and I don't know if the designer finished its work or just left it unfinished, because in this state this design with the brilliant idea of shifting the trains between the loops has kind of disadvantage. That disadvantage makes this flip-flop let's say not entirely reliable. And why? Because the train can get stuck, and the train can be blocked by the combo signals, and if it is blocked like right now, it will not shift. It will keep open the same branch for the next train, and it means that the 2 trains in a row will go through the same branch, and that can happen with every branch in this design. So we can say there is no fail-safe that will prevent it, and those trains are not evenly distributed, and we really do not have any control over this over here. So I decided to make, let's say, my version and try to remove disadvantage from design. So let's have a look how this is done in my case. So what we have on the screen is a modified, improved version of what we just have seen on this old map. So this system over here, this circuit over here, do not allow the train to get blocked at any of those double combo signals, and that's done thanks to these two signals blocking and exit signals put kind of in a strange way, but that's the the trick, that's the magic that we need to use over here, and this makes the system over here perfect, and that system perfectly distributes the train evenly along through this splitter over here without any mistakes. So I would like to, and then I let's say that after I built this one, I decided to try to build this one, which was quite let's say very easy, and then I built this one, and then the last one. All those working, all those splitters, no splitters, all those flip-flops, they working perfectly. So I think I should start explaining the one over here, because it's the simplest one. So if you understand this one, you will understand the rest. Now, like I said previously, this one is very very reliable, and as well it uses actually very little resources. We have one train over here. However, it's not the smallest one. Yes, if you, for example, look at this one over here, it looks like even it's smaller. We're using over here NOT gate with the two trains. However, you can use a NOT gate with the one train, but then will be a bit bigger. One memory, but this is based on penalties. So when you use something that is based on penalties, it's not entirely reliable. So for example, right now it is working perfectly. Yes, so right and left, but if I connect, if I change something in the network after the splitter, it will change penalties. So if I do it this way, let me do it this way, so, and put some signals so we don't have a too long a gap. We can even do over here. Let's have a look what will happen. And now all the trains go to the right hand side, even despite the fact that we have a penalties over here much higher it seems to be, but they prefer to go this way. All right, so I guess that's not the best solution. So penalties were never actually the best solution. This solution for many things, but it's not the best. So I guess that we're going to I'm going to use this one, and we start now explaining this one. Before we start, let's say something about the setting. On the screen we have a setting which is required to make all those logic things working. So if you need more time, just pause video. We go with this further. Now, to make it work, every flip-flop requires some kind of splitter and signaling and device or a circuit, control circuit, that will allow us to change what is open and what is closed. So in our case, we're opening one on the, let's say, right, and then one on the left, and then when the train will passing, we want to close the one when it's passing and open the other one, so like it is now. To do it, we have this control circuit which is built with the two loops. We have two double combo signals in this loop. Then we have a waypoint. This is the same waypoint, it's just placed in two places, and we have a very strange situated blocking signal with exit signal. They done this way by purpose, and I will explain it later why. Without this circuit will not be the same. It will not work so perfectly like it is now. Now the train, I've got over here order to go to this waypoint, and the Pathfinder is always looking for the shortest way to get to the waypoint. As long as there is this combo signal is open, the train will go to the closest waypoint. Now when this double combo signal become red from both sides, the train will be forced to go straight and shift to another train, to another loop. Sorry for that. Now one more thing why we have over here double combo signals, because if we have a single signals, now there is no end of line, and the pathfinder will be looking always which way is better from the penalty point of view. Let's have a look, and bam, it is not end of line, and pathfinder doesn't care about this, that this is red. It could go left, but it didn't. It prefers the right way, so it is stuck. So to prevent it, we need to just have it, we need to create end of line by using a double signal. So that's why we have it. Let me unpause the game, and now everything will come back to normal. What I said, what I didn't say. Now, to make it work, we need to, of course, connect those things together. Now, the connections where it's left is looking into this loop, is connected to this loop, and is looking if there is a train. There is no train, so thanks to that there is no train through all those combo signals here. This one can be green. Now the other one is red because it detects the train in this loop through those combo signals here. Now this connection has another purpose. It let's say triggers, it forces the train to shift, and it is done this way that when the train gets, in this case, onto this tail, the exit signal become red. That connection is connected to the track, to the loop where the train is looping. The other one is to that empty one right now, and because of that, this one become red, and thanks to that, this combo signal in a moment become red from both sides, and that means end of line, and it will force this train to go straight and shift. So as you can see, still is red from the one side, but now it detects the train from this side. Now thanks to those two exit signal, this side sees actually is red as well. So this is end of line for the pathfinder, and pathfinder will now force this train to go straight instead of turning right into the loop. So we're shifting. So very simple method, and I will explain a bit more about this in a moment. I think that's all about the basics things. Let's talk about failsafe. So let's have a look now at the failsafe, and I purposely stopped this train because I want to simulate the situation that something could go wrong if we don't have a failsafe. So let's say that we are in the situation where our train in the loop approaching the junction, when it can go straight and shift, or it can go right towards our waypoint, the closest waypoint, and at the same time the train in this splitter approaching the right branch combo signals. So let me first unpause this one, and now let's move one more step. That's what we wanted. Now let me stop it, because otherwise we will not get what I want. And now unpause this one, and let's wait till it gets touch the combo signal. What? That's it. Let's stop it for a moment. So we are at the position where without failsafe this loop will be locked, and so if I remove this signal, you will see immediately that this signal over here, the combo signal, is red. It means that this train in this position will be blocked, and it will not shift. We will prevent the shifting. It means that I will not change how the splitter is open, so we will still have the right branch open and the left branch closed, because that train will be stationary over here. It will be stationary over here till this train will remove itself from the last from the blocking signal, from the tail with the blocking signal, and the next train will come exactly along the same branch. So let's say, distribution of the trains along this splitter will not be even. But now if we used exit signal, everything will be working. Now if I put it over here, it's a wrong position. Why? Because there is another problem coming if I do it this way. If I do it this way, we will get over here a tail where is a kind of gap, yeah, and when we will get this gap over here, this combo signal will start flashing. We have the same situation in the other loop. They both will be flashing, and then our train will be able to choose a different that we think it could branch. So by putting this combo signal here, we do not leave any empty gap, and we have this train and this combo signal constantly red when the train is looping this loop. Yeah. So let's now unpause. So we're going to start this one. We're going to start this one and do it slowly. So we're moving. So what is happening now? So we are approaching this. Let me this way. Oh. So now we have a situation where our actually double combo signal over here become end of line. And why it become end of line? Firstly, we have the exit signal red and this signal exit signal red. So there is no train in the block, but our combo signal over here performs let's say logical equation and so red is 1, so 1 and 1 equals 1, so that's why we have a red. And now the other side of the signal, this one over here, sees the physical presence of the train over here, and that's why both are red, and we have we just created end of line. And now the pathfinder will not go right like previously, but it will force to go straight and shift to another loop. But let's do it slowly, so we can set what will happen with this tail over here, with the signal actually along this tail. So as you can see right now, this signal, exit signal, is red. And there are not many players, I think, know about this, but this is very useful when you create some kind of let's say more advanced circuit, so it's good to know. So our exit signal is red because it sees the train ahead. That's obvious. But what will happen next? So let's make in one step. Now our, let's say, middle of the train is just at the middle of this tail. Still exit signal sees this train over here. Let's move one step further. Now we just passed the blocking signal over here, which is in the middle, but our exit signal still is red. Now why? Why? Because actually the blocking signal represents what the state of this tail is. So this tail is actually in the state of that there is a train, but as well this is a blocking signal. Yeah. So this exit signal looks not in the gap between those two signals, but in this whole tail. So as long as there is a tail, this exit signal, sorry, as long as this train is in this tail, this exit signal will see this train, the presence of this train on this tail. Now we have to take in account that actually Pathfinder looks in the middle of this engine. The same, it will be the middle of the wagon, the last wagon, yeah, of the train. So now let's move one step further. And we just moved our middle of the train out of this tail where we have a blocking signal, and immediately our exit signal become green. Yeah, so that's why it has to be so close to this. Actually, it has to be so close to this because thanks to that, there is no gap between those two signals, and this combo signal sees immediately when we just touch this blocking signal, this tail with the blocking signal, that there is a train, and it will be it will keep constantly red while this train is circulating this loop. So that's why. Okay, so that's actually everything what I wanted to say. So actually I would like to finish. There's nothing else to add. I hope you like it. It's really interesting design, a kind of simple one, really simple one. And let's have a look at this. Seems to be that everything is working perfect because everything is in line, so there are not mistakes. So yeah, thank you for watching. I hope that was interesting video. If you like it, please like it on YouTube, and if not, what I can say. And I'll see you in the next video, sometimes in the future, not necessarily in OpenTTD. Thank you and bye bye.